everyone. I am Officer Julie of the Mathematics Pre-Service Teachers Association of Libon Community College. One of the purposes of our association is to make learning mathematics easier and more interesting to the learners in mathematics. Our organization wants to reach all interested learners through the internet. So, let's start! Hello guys, welcome back. So in this video, I am going to talk about parallel lines, polygons, triangles and congruent triangles, and quadrilaterals. I'm going to give you the meaning of each and show some real-life example also. So what is a parallel lines? Parallel lines are lines in a plane that do not intersect. So next, here are some examples of parallel lines in real life. Zebra crossing, electrical wires, edges of a ruler, fork tins, keys of a piano, markings on roads, and many more. Polygons are all around us. Most common shapes that you see every day are polygons. There are thousands of examples, but first, what is a polygon? What makes a polygon a polygon? Polygons is a plain closed figure made or formed by three or more line segments. So, we're going to break that definition down and make it a little easier and simpler. Now, when it comes to polygons, there's a checklist and a polygon has to have a check next to each of these three characteristics. So, we're going to go through what those three characteristics are. But before I start that, when it comes to polygons, they have specific names. So for example, a three-sided polygon is a triangle. A four-sided polygon would be a quadrilateral. I'm going to go through those specific names later. So, let's get back to what makes a polygon a polygon. So the first characteristic or thing in our checklist, a plane figure or plane shape, that just means the figure or shape has to be flat. So if it is a three-dimensional like a cube, a pyramid, a rectangular prism, those are not a polygon. So again, it has to be flat. Next, closed. So a closed figure or shape, and that's exactly what it sounds like, it has to be closed. So I will give you a counterexample. That's not a polygon. So let's say we almost have a rectangle here, but we have this opening. That would not be a polygon because it's not closed. So not a polygon. Then lastly, made of line segments. This means that there cannot be any rounded edges. So for example, actually a counterexample, a circle. A circle, yes it's flat, yes it's closed, but it's not made of line segments. A polygon has to have a check next to each of these three things. So a circle is not a polygon. Another counterexample would be a figure like this. It's looking like it will be a rectangle, but we have a rounded top here, so not a polygon because it's not made of all line segments. Now, can you tell me which one is a polygon and which one is not? Well, the first figure is a polygon since it is closed with straight line segments, while the second figure is not a polygon since it is an open figure. Let's have another one. Which one do you think is a polygon and which one is not? Well, the first figure is a polygon since it is a closed figure with straight line segments. And the second one is not a polygon since it has curved line segments. So now, let's explore some objects and how to name polygons. First up, we have here a piece of pizza and it has 3 sides or 3 line segments. This polygon is called triangle. A triangle has 3 sides and 3 angles. Here are some examples of triangles. Next one, we have here a chessboard. This object forms a polygon with 4 sides and it is called quadrilateral. A quadrilateral has 4 sides and 4 angles. Here are some examples of quadrilaterals. Other quadrilaterals are square, rectangle, parallelogram, rhombus, trapezoid, and many more. I will tackle these quadrilaterals more on the later part of this video. Let's go to the next one. We have a flower. We can form a 5-sided polygon from this flower and we call this as pentagon. A pentagon has 5 sides and 5 angles. Here are other examples of pentagon. Let's go to the next one. We have here a honeycomb. This honeycomb has 6 sides and a polygon with 6 sides is called hexagon. Hexagon is a polygon with 6 sides and 6 angles. Now, here are other examples of hexagon. Moving on, we have here a cactus. This one has 7 sides and a polygon with 7 sides is called heptagon. Heptagon has 7 sides and 7 angles. Now, here are other examples of heptagon. Perfect! Now, let's go to the next one. We have a medal. This medal has 8 sides and a polygon with 8 sides is called octagon. Again, octagon has 8 sides and 8 angles. Here are other examples of octagon. Next up, we have here a dishes. This object has 9 sides and a polygon with 9 sides is called nonagon. Nonagon has 9 sides and 9 angles. Here are other examples of nonagon. Another object is a star. This star has 10 sides and a polygon with 10 sides is called decagon. Decagon has 10 sides and 10 angles. Now, here are other examples of decagon. Next one, we have here a coin. This coin has 11 sides. Now, a polygon with 11 sides is called andecagon. Andecagon has 11 sides and 11 angles. Here are other examples of andecagon. On to the last one. This object has 12 sides. Now, a polygon with 12 sides is called dodecagon. Dodecagon has 12 sides and 12 angles. Now, here are other examples of dodecagon. There is a regular and irregular polygon. But first, what is the difference between regular and irregular polygons? Regular polygons is both equilateral and equiangular. When we say equilateral, this means that equal sides, while equiangular, this means equal angles. For example, a square has 4 equal sides. The tick marks on the line segments shows that they are congruent or equal. It means that when one side is 4 cm, the other sides are also 4 cm long. This means the square is equilateral. Also, we know that square has 4 right angles, which means it is also equiangular. Since the square is both equilateral and equiangular, this means it is a regular polygon. Now, unlike regular polygon, irregular polygon has sides and angles with different measure. For example, a rectangle has 4 right angles. It means it is also equiangular, but a rectangle has only 2 pairs of sides equal. One pair is the length. It means that if one length is 5 cm, the other one will also be 5 cm long. Now, the other pair is still width, which are also equal. It means that if the width is 2 cm, the other one will also be 2 cm wide. Now, even though a rectangle is equiangular, we can see that not all its sides are equal. This means that rectangle is not equilateral, therefore it is an irregular polygon. We are now on the third part of our topic, that is all about triangles and congruent triangles. In the word triangle, tri means three while angle means angle. It means that triangle is a polygon formed by three angles. Triangles are classified according to their number of congruent sides. These are equilateral triangle, isosceles triangle, and scalene triangle. An equilateral triangle has congruent sides. An isosceles triangle has at least two congruent sides, and a scalene triangle has no congruent sides. Triangles are also classified according to their angles. These are acute triangle, obtuse triangle, and right triangle. The measure of the three angles of a triangle is equal to 180 degrees, and in every triangle, there are at least two acute angles. The third angle is used to classify the triangle. If the triangle has three acute angles, it is called an acute triangle. An obtuse triangle is a triangle with one obtuse angle, and a right triangle is a triangle with one right angle. Triangles with all angles congruent are called equiangular triangles. Equilateral triangles are equiangular. These are examples of triangles in real life. A slice of a pizza, a chips, a sandwich, a hanger, a ruler, and a road sign. The next one is congruent triangles. Triangles that match each other exactly are called congruent triangles. The parts of congruent triangles that match and are congruent to each other are called corresponding parts. The two triangles in the figures triangle ABC and triangle XYZ are congruent. It is denoted by the symbol of triangle ABC congruent to triangle XYZ, where the symbol congruent is read as congruent to. In this case, angle A corresponds to angle Y, angle B corresponds to angle X, and angle C corresponds to angle Z. Also, side AB corresponds to side XY, side BC corresponds to side XZ, and side AC corresponds to side YZ. It is important to note that if two triangles are congruent, their corresponding sides and their corresponding angles are congruent. Two triangles are congruent if some corresponding parts are congruent to each other. There are methods of determining whether or not two triangles are congruent. These are stated as theorems and proven in geometry books, but we will omit its proof here. These are the side-side-side, side-angle-side, angle-side-angle, and angle-angle-side. Side-side-side or SSS rule is a rule used to prove whether a given set of triangles are congruent. This rule states that if three sides of one triangle are equal to three sides of another triangle, then the triangles are congruent. In these two triangles, we can see that triangle ABC is congruent to triangle PQR since side AB is congruent to side PR, and side AC is congruent to side PQ, and side BC is congruent to side QR. The two triangles are proven by the side-side-side or SSS theorem. The second rule is the side-angle-side. This rule is used to prove whether a given set of triangles are congruent. The SAS rule states that if two sides and the included angle of one triangle are equal to two sides and included angle of another triangle, then the triangles are congruent. An included angle is an angle formed by two given sides. In these two triangles, we can see that they are congruent. Triangle ABC is congruent to triangle DEF since side AC is congruent to side EF and side AB is congruent to side DE and angle A is congruent to angle E. The two triangles are proven by the side angle side or SAS rule. The third rule is the angle side angle. This rule is used to prove whether a given set of triangles are congruent. The angle side angle states that if two angles and the included side of one triangle are equal to two angles and included side of another triangle, then the triangles are congruent. In these two triangles, we can see that they are also congruent. Triangle MNO is congruent to triangle STU since angle N is congruent to angle U and angle O is congruent to angle S and side NO is congruent to side SU. These triangles are proven by the angle side angle. So the last rule is the angle side. This rule is used to prove whether a given set of triangles are congruent. The angle side states that if two angles and a non-included side of one triangle are equal to two angles and a non-included side of another triangle, then the triangles are congruent. We are now on the last part of this video and it is all about quadrilaterals. Quadrilateral just means four sides. Quad means four, lateral means side. A quadrilateral has four sides. It is two-dimensional, closed, and has straight sides. A quadrilateral is a plane figure that has four sides or edges and also has four corners or vertices. The angles are present at the four vertices or corners of the quadrilateral. If ABCD is a quadrilateral, then angles at the vertices are angle A, angle B, angle C, and angle D. The sides of a quadrilateral are AB, BC, CD, and DA. If we join the opposite vertices of the quadrilateral, we get the diagonals. In this figure, AC and BD are the diagonals of quadrilateral ABCD. Properties of a quadrilateral. A quadrilateral has four sides, four vertices, and the interior angles are equal to 360 degrees. Here are other examples of a quadrilateral. We come now to kinds of quadrilaterals. First is the square. A square is a quadrilateral with all four sides congruent. Properties of a square. First, all the sides of the square are of equal measure. Second, the sides are parallel to each other. Third, all the interior angles of a square are at 90 degrees. And last, the diagonals of a square perpendicular bisect each other. Here are some real-life examples of a square. Chessboard, a clock, a biscuit, chocolate, and a photo frame. Next is a rectangle. A rectangle is a quadrilateral with four right angles. Properties of a rectangle. First, the opposite sides of a rectangle are of equal length. Second, the opposite sides are parallel to each other. Third, all the interior angles of a rectangle are 90 degrees. And last, the diagonals of a rectangle bisect each other. Here are some real-life examples of a rectangle. Floor mat, brown envelope, and many more. Third kind of a quadrilateral is a parallelogram. A parallelogram is a quadrilateral with two pairs of opposite sides parallel. Properties of a parallelogram. First, the opposite side of the parallelogram are of the same length. Second, the opposite sides are parallel to each other. Third, the diagonals of a parallelogram bisect each other. Fourth, the opposite angles are of equal measure. And last, the sum of two adjacent angles of a parallelogram is equal to 180 degrees. Examples of a parallelogram in real life are erasers, steps of a staircase, solar panels, and many more. Fourth kinds of a quadrilateral is a rhombus. A rhombus is a quadrilateral with all four sides congruent. Properties of a rhombus. First, all the four sides of a rhombus are of the same measure. Second, the opposite sides of the rhombus are parallel to each other. Third, the opposite angles are of the same measure. Fourth, the sum of any two adjacent angles of a rhombus is equal to 180 degrees. And last, the diagonals perpendicularly bisect each other. Here are some examples of a rhombus in real life. Gardening tools, cookies, mirrors, keychain, and many more. Other kinds of a quadrilateral is a trapezoid. A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Properties of a trapezoid. First, only one pair of the opposite side of a trapezoid is parallel to each other. Second, the two adjacent sides of a trapezoid are supplementary. And last, the diagonals of a trapezoid bisect each other in the same ratio. Wonderful job, guys! You made it this far. Now here are the things that you learned today.